some square brackets and just type volume here. We haven't that we on row 2. Should we check? Date 2022-01. There's another in the end in here. But this wouldn't work right now, right? Because we haven't done this trick of defining this as the index. But anyways, if we had done that, we would use indeed not to do this accessing of the rows, but we could still use and then give numbers. So this iloc will always keep track of this ordering, so that's why both exist. Now you might be thinking, how do we access an actual value within that data frame? So let's go back to the example where we were using 2. So that was giving us this line with index 2, so let's say we wanted to access the volume. Well, you would open some square brackets and just type volume here, and if you did that, you'll see that you'll get exactly the volume. Actually, you could do it this way, but you can also do it in this way here as well. So that was giving us this line with index 2, so let's say we wanted to access the volume. Well, you would open some square brackets and just type volume here, and if you did that, you'll see that we'll get exactly the...
did not work. Why? My brackets are wrong. There we go.
Volume. Actually, you could do it this way, but you can also do it in this way here as well. The same will work.
Want to go back to school in 2026? You'll need to use waiving your application to Deed for February, since it's a great time to do that.
Now, let's say that you actually didn't want to just get the volume, but say the volume and the close. So you can actually give the list of the columns you want to get the values from. So I added the 1 square bracket, then I'll put a close here, and I'll have to add another square bracket. And if I run this, you see that we get the volume and the close. And in the same way, I did it that here, but you could do it like this here as well, no problem. Also, by the way, I didn't mention that before, but in the same kind of way, if you only wanted to get the full column, but let's say 2 columns in that data frame, well, you could simply do exactly the same, do like that. And this will give you the 2 columns that you asked for. So you see, I'm repeating myself, but essentially what I'm giving here within the df square bracket is a list of the column names that I want to get access to. Something else we can do is also filter the values in the data frame given a condition. So here simply write, for example, df of, let's say, volume. Oh, I forgot the little apostrophe. Okay, now 1300. Okay, I run this, what do we get? We get false, 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 false. Why is that? Well, because none of these conditions give us something larger than 1300. So if I did, let's say 250, what would we get? We would get one that is true, indeed this one here, because we have 1300 at this location here. And note that I did do a strictly superior. If I did a equal, that would have made it so that number, the index 3, this one also is now true, because it's superior or equal to 1450. Okay, this was a nice little feature, but what we really want to do is actually get the values, the rows, etc. that satisfy this condition, not just to know which one or not satisfies this condition. So now what do we do? Well, this is really the beauty of pandas. Well, we'll simply do exactly the way, I removed that example, but when we were testing indexes to get superior apostrophe, okay, larger than 1300. Okay, I run this, what do we get? We get false, 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 false. Why is that? Well, because none of these conditions give us something larger than 1300. So if I did, let's say 250, what would we get? We would get one that is true, indeed this one here, because we have 1300 at this location here. And note that I did do a strictly superior. If I did a equal, that would have made it so that number, the index 3, this one also is now true because it's superior or equal to 1250. Okay, this was a nice little feature, but what we really want to do is actually get the values, the rows, etc. that satisfy this condition, not just to know which one or not satisfies this condition. So now what do we do? Well, this is really the beauty of pandas. Well, we'll simply do exactly the way, I removed that example, but when we were accessing indexes to get the rows, we'll do exactly the same thing. We'll do df of lock, but this time lock of what? Well, lock of that condition here. So you'll see if I run this, we'll get the only two lines which satisfy this inequality here. So indeed, this row here, so index 2, this one here, and index 3, this
not
one
running.
here as well. Great. And you can actually really...
I don't know why it isn't running. It's odd. Yeah, if I save it, exit out. I want to save all of these. Better than working before. Volume is greater than DF lock. Says DF is not defined, but it should be.
We'll do exactly the same thing. We'll do df of lock, but this time lock of what? Well, lock of that condition here. So you'll see if I run this, we'll get the only.
Okay, I love you.
Two lines which satisfy this inequality here. So indeed, this row here, so index 2, this one here, and index 3, this one here as well. Great. And you can actually really complexify this. And for example, we say we wanted to find the line that satisfies two conditions. So I'll just put this first condition in parentheses, and then I'll put this and symbol.
Says trace back most recent class name of DF is not defined. That's because I didn't take this out of here and then run this. Okay, no, that's not why. Print EF volume. Close. What is going on? I think that the type is right, and I think it's formatted correctly. It's still saying name DF is not defined.
And that square bracket is a list of the column names that I want to get access to. Something else we can do is also find the values from. So I added the one square bracket, then I'll put a close here, and I'll have to add another square bracket. And if I run it, you see that we get the volume and the close. And in the same way I did it that here, but you could do it like this here as well, no problem. Also, by the way, I didn't mention that before, but in the same kind of way, if you only wanted to get the full column, but let's say 2 columns in that data frame, well, you could simply do exactly the same, do like that. And this will give you the 2 columns that you asked for. So you see, I'm repeating myself, but essentially what I'm giving here within the DF square brackets is a list of the column names that I want to get access to. Something else we can do is also filter the values in the data frame given a condition. So let me simply write, for example, DF of, let's say, volume. Oh, I forgot the little apostrophe. Okay, larger than 1,300. Okay.
See, now it's saying this isn't defined up here.
If indeed the close.
But it was working yesterday. I think this is defining it. I don't understand. Yeah, because data equals, and then we're saying that the data frame, we're saying that the DF is data, so we're defining it as the data. Saying PD is not defined. But we're saying PD is pandas.
just like it should, and here it's telling us that it's a flow 64. So basically the object that characterizes decimal numbers. And lastly, if I put volume here, since we define the volume to be integers, then the D type that we'll see here should be integers. So we do have N64. All good. Great. By the way, I'm Louis, in case you don't know me. On this channel, our goal is to of this that satisfy the two lines, and note that here give numbers. So this ILOC will always keep track of this ordering. So that's the index column. For example, you could say that in the end, how about using the date as the index column? So what I should say, if you want to print a print, so you would do print, then you df dot index. And if you run this, what you'll get is actually an object, a range object. You see starts from 0, stops at 4 with step 1. This is the same kind of thing that
Alright, let me see. What the heck?
Falling behind your competition? Use SEMrush's Traffic and Market Toolkit to track their strategy, benchmark AI traffic sources, and get actionable audience data.
hundreds of times. So we can run that cell version of the package, but also it meant that we've called a method within this package and it works fine. So it's a proof that everything was done properly. Great. Now that we've successfully imported pandas, we can discover that pip install is not going to work, and you should then try pip 3. It depends how you have installed Python. So just on the, and then the e dot call actually the version of the package. And if that runs, that means everything's fine. We do get indeed the number version of the package, but also it meant that we've called a method within here, this example here, and I'll paste it in the code. Okay, so let me explain what we have here. So this, you remember, those little curly brackets mean that this object here that we're defining is a dictionary. So we're defining this data dictionary. What do we have in this dictionary?
So now it's working. Okay.
TVDF to start name. Give type do resonate with amps like it should, and here it's telling us that it's a flow 64. So basically the object that characterizes decimal numbers. And lastly, if I put volume here, since we define the volume to be integers, then the D type that we'll see here should be integers. So we do have N64. All good. Great. By the way, I'm Louis, in case you don't know me. On this channel, our goal is to democratize algorithmic trading and quantitative analysis in finance. So if these topics do resonate with you, register for some access. You got volume. Again, you should access this as the index. But anyways, let's say that it is indeed locked to do this accessing of the rows, but you could still use, you might be two that will get set this by column. For example, you have it that, well, you would have, but you can, so you could add a square bracket. And if I run this,
So then we were doing print df. Volume. we're working.
You see that we get the volume and the close. And in the same way, I
It
did
wasn't registering PDS pandas from up top. We had to redo that whole thing.
So, by the way, I didn't mention that before, but in the same
Oh my gosh.
you only wanted to get the full column, but they say 2 columns in that data frame, well, you could simply do exactly the same. Do like that. And this will give you the 2 columns that you asked for. So you see, I'm repeating myself, but essentially what I'm giving here within the df squared bracket is a list of the column names that I want to get access to. Something else we can do is also filter the values in the data frame given a condition. So let me simply write, for example, df of, let's say, volume. Oh, I forgot the little apostrophe. Okay, larger than 1,300. Okay, I run this. What do we get? We get false, 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 false. Why is that? Well, because none of these conditions give us something.
Alright, it's working now. Yeah.
So
We did
if I
it.
did say 250, what would we get? We would get one that is true, indeed this one here, because we have 1,300 at this location here. And note that I did do a strictly superior. If I did a equal, that would have made it so that number, the index 3, this one also is now true, because it's superior or equal to 1,250. Okay, this was a nice little feature, but what we really want to do is actually get the values, the rows, etc. that satisfy this condition, not just to know which one or not satisfies this condition. So now what do? Well, this is really the beauty of pandas. Well, we'll simply do exactly the way, I removed that example, but when we were accessing indexes to get the rows, we'll do exactly the same thing. We'll do df of lock, but this time lock of what? Well, lock of that condition here. So you'll see if I run this, we'll get the only 2 lines which satisfy this inequality here. So indeed, this row here, so index 2, this one here, and index 3, this one here as well. Great. And you can actually really complexify this. And for example, we say we wanted to find the line that satisfies 2 conditions. So I'll just put this first condition in parentheses, and then I'll put this and symbol, and what should we ask for? Let's put a condition on the close as well. So let's say close, and let's say close bigger, larger, or equal to, well, let's do strictly superior to 153. So in principle, what we should find is indeed this column here, this row here, beg your pardon. So then we run it, and indeed it is what we find. So I did with an and, but we could also do with a or. And for this you need to put the vertical bar here. So this is the symbol for or, and you can see indeed that we do get this line because this line here, this row here, satisfies which one? It satisfies this one. But it doesn't satisfy this one. But because it is a or, then it satisfies this larger condition. So it gets this line, and actually this second line here, so the index 3 of our original data frame, this one actually satisfies both conditions at the same time. So that's why we get it. But if I had put, for example, a 1,300 here, you would get the same thing. Because now this line doesn't satisfy the volume condition, but it does satisfy the close conditions. So that's why it's here as well. Let me also mention that you can carry on, obviously you can carry on piling up. You can put more conditions here. But let's say rather than now accessing, getting all the lines of this that satisfy this condition, we only wanted to get the volume that satisfy this condition, then it is the same kind of thing that we did before. If you want to isolate the volume, the corresponding value to the volume column, you come here and you put the volume, and then you do that, and you can see that we now get only the volume values that we saw before. Great. Okay, so we've seen how to handle a data frame, access some of its values, etc. But honestly, the data set that we created is tiny, and we could have easily done all of these tests without pandas. But now it's time to crank things up and fully exploit the power of pandas. In general, a large data set will come in the form of an Excel file, or more generally what we call a CSV file. Sometimes indeed you do have some JSON files or even some databases like SQL. But most often it is CSV files, but that's what we are going to train with. Just think about them as a written format of an Excel file. So an Excel file in the text format, I should say. As you might have guessed, with Pandas you can directly read CSV files. So I prepared one for us to use. So come on this chapters page and click on this link here. This will send us to the GitHub of our channel. So GitHub, if you're going to use, so come on this chapters page and click on this link here. This will send us to the GitHub of our channel. So GitHub, if you're going to be a programmer, you're going to be using that a lot for sure. This is where we store all our open source codes that we develop in our YouTube videos. So feel free to navigate and go see what we have in store. Anyways, so this file that we have here represents the evolution of the Apple stock over, I think, the past 5 years. So you see that now this is a much bigger data set. We have actually how many? 7 columns, and I think in terms of rows there's a lot, about 3,000 I think. Let's see. Yes, indeed, 2,921 to be precise. So what you do from here is you can download this file by clicking on this icon here, and if for some reason this doesn't show up, you can always go and click on raw here, and you'll just see simply this file displayed in its raw version. And you can see that basically what happens is that each each column are separated with a comma. That's really the structure of the CSV file. And here you can just simply right click and click on save as or something that's like that. And once you've done that, you simply save this file and put it in the folder where you have the code of this chapter. And you'll see that once you've done that, it will also update in VS Code, and you can see that now it has appeared in the folder where I have all the codes for this Python course. So just remember, put this physical file in the physical folder where you have this chapter5.ipython or whatever name you've given it. And if you want to see, you can actually open it, and you can see that here in VS Code, the CSV file has some nice colors to differentiate between the columns. And this is because I've installed a package, and I believe the name of this package is Rainbow CSV. Yes, this one, Rainbow CSV. So you can come here and install it. You can see that I've already installed it anyway. And it's quite probable, by the way, that the first time you actually open a CSV file within VS Code, you're going to have a little window coming up here telling you, do you want to install Rainbow CSV? Anyways, great. So that's done. And now what we'll do is to import all the data in this file and store it into a data frame. So we'll do df equal, then pd dot, and then we're calling the method to read a CSV file. You can actually see here that you can read many files. CSV, Excel, you also see JSON here, but yeah, our file is CSV, so we'll go for read CSV. Then in between parentheses, we simply have to give the name, so app, appl, and VS Code even suggests it already. Okay, so let me then print what we see, and you can see that it looks exactly like what we saw here, but indeed with much more information. You can see that it gives us the number of rows and columns. Note that there's one less here because in our file, when we counted on GitHub, it counted also the names, the comment that was the name at the very beginning of the code. But here, when it stores in the data frame, it really gives you the number of rows that are of digital numbers, not the commented line. Anyways, so you see all our columns. So columns is time, open, high, low, close, volume, volume element. So this basically is the evolution of the Apple stock. So this format of a file is very well known as what we call OHLCV. So indeed, open, high, low, close, volume. This is generally how we store the information about the evolution of a market or an asset that you can trade. And actually, let me show you how this looks like on a trading charting software. So let's head over to TradingView, which is widely used, and you can also access it directly from the internet. So this is the Apple stock, its market, and the data file that I showed you before basically represents exactly this. So these open, low, close, volume, etc. values refer to these candles that you see here. So how do you understand a candle? Well, it is the evolution of the price of the stock that you're looking at, so Apple stock, during a given trading session. So this is a daily chart. So this candle spans over a day. And how do you read this? Well, actually it's pretty intuitive when you think about it. So a green candle means that the value of the asset grew across that trading session, while a red one means it decreased. So for a green one which grew, well, the open value is shown, is displayed by the bottom of this candle here, this rectangle, I mean. And the top value will therefore mean the close value. So bottom open, top close. And then the lowest value that was achieved or reached, if you want, during this trading session is shown by the wick of the candle. So this little, if I put my mouse, I have this little line that comes in, so you don't see very well, but it's this thin line that goes across the candle here. So the bottom of the wick here displays the lowest, while the top of the wick here displays the highest price that was reached during this trading session here. And on the red candle, so a decreasing candle, it's the same kind of thing, if you want, but reverse for the open and the close. Because this is red, it means that the open is now at the top of this rectangle, while the close value is at the bottom of this candle. And the wick is actually the same than for the green one, so this highlights the lowest price that was reached during this trading session, while this one is the highest. And the volume cannot actually be displayed with this candle, so if the volume is an extra indicator if you want, and just to show you, you can add it here by going on indicator and type volume, and then you can see it displayed here. So this is the volume reached. So the values here corresponds to the amount or the volume trading during this trading session, and you have that for all the candles here. So you see, if I come back to our code, you see exactly the thing. So the time is indeed the time of that session. So there's a little thing we need to do to these numbers to get an intelligent effect. You'll see that in the future, but you do see indeed exactly open, high, low, close, and volume. Volume MA, I don't exactly know what it is. I assume a moving average computed over the volume in maybe a specific way. But anyways, we're not going to be using that today, so we will actually use this example to show you how to delete a column from a data frame. We'll do that in a bit.
Build an app that works my way with Base44. My work moves fast.
Okay, now let's put ourselves in the shoes of a data analyst. So when you get a data set like this, the first thing you need to do is to do a first-hand analysis of the data set. Because in general, when you get a data set, it won't be clean. There will be some things missing, maybe some errors at some point with the formatting, some numbers missing, funny things like this that you have to deal with. Obviously, when you do an exercise and somebody gives you an example to treat like we're doing here, the data is generally clean, but just know that in a more professional context, or actually say less pedagogic or whatever, you'll have to do this cleaning of the data. So the first thing I suggest is to use a very nice method from Pandas, which is called describe. So we'll just do this, describe. So this basically gives you a first-hand statistic analysis or breakdown, if you want, of the data set. And as you can see, what it does is that it analyzes this data set and gives you the count, the amount of values basically contained in the column time, then the mean of these values, so again in the column time here, but for each columns, the standard deviation, the minimum, these are quartiles, I'll tell you in a minute, and the maximum values. You can see, however, that when the numbers tend to get big, pandas automatically changes the format of the numbers, and here it's giving you a scientific format, which we may not need here. So just remember, E plus 03 basically means 2.92 times 10 to the power 3. So E plus 03 means 10 to the power 3. So here, I guess we don't really need that. We are happy with what we had before. So I'm just going to fetch this little command on the website, and then we'll come back to the code and put it here. If I
Hold on. P.set option. Display, is that what it was? Display float format.
run this, then I run this again, you see it will put it back into how we wanted it before, how it was before. Great. So I mentioned I wanted to explain what are those quartiles. I think the count, you can see by the way that little thing that you see, but there is a little non-clean thing happening in this data set, and you've probably seen it before, is that this line misses numbers, but you actually would see it here. You see like, oh, in the time column I have 2,920 values, the same for open, oh, but now the rest of the columns have one less. So probably I won't be able to use that last line because I'm missing information. Cool. So that's a little thing that this describe tells us. Okay, then you want to have some physical understanding of your data set. That's where the average, the mean comes in handy, the standard deviation as well, the minimum value and the maximum value as well. Now the quartiles, what does it mean? Well, this 25% here means that 25% of the values have an open value that is in between 0 and 21.83. Then this 50% line here, how should you understand it? Well, for the open column, it means that 50% of the data in the whole data frame have open values, beg your pardon, contained between 0 and 36.49. And you can understand how it goes on. Now the 75% quartiles tells you that 75% of the data set has an open value in between 0 and 93.83. Of course, I'm giving the example for open, but it's the same for all the columns. Say, for example, we're now doing high, we're looking into high, so it means that this number here means that 75% of the data in the whole data set has values of their high that is contained between 11.27 and 94.55. And you understand now also in this sense the maximum, it actually means here the max is like 100% quartile. It means that 100% of the data in the data set has an open value contained between 0 and 182.63. Now there's a few things we said we should do to this data set. We did say we wanted to change this data into something intelligible because these numbers don't mean anything to us per day. And we also said that we will remove this volume MA column, and we also have to deal with this little irregularity that we have here where there's more values with time and open but not high, low, close, etc. But actually this little table shows that there's something else that's a bit weird happening in our data set, and it's actually this number here. So this tells us that the Apple stock actually had a value of 0 at some point. And that's not really possible at all. Stocks, even at the beginning, don't start with a value of 0. So there's probably something happening here that we'll have to deal with. Okay, let's start cleaning this data now. So I think the first thing we should do is to actually remove that last column that we don't want. So we'll do df equal df dot, and we'll use this method called drop. And in drop, we must give the name of the column, so volume, MA, and we need to specify that this is a column and not a row. So that's why we need to give after that axis equal 1. Then let me display the data frame again. And there we go. The column has disappeared. Perfect. What else should we treat now? Well, let's get...
That did not work. There we go. No, that still did not work. Why is it? Okay. My numbers are different. Why the hell are the numbers different? Okay, there we go.
To that missing data kind of that we have to deal here, where we saw that there is one too many if you want, or there is some missing high and low volume close data. So this probably means that somewhere there's some data that is null. So for that, we're also going to use a method to spot these null numbers. Indeed, I've mentioned it already before that this is probably the line, but yes, let's imagine that we hadn't seen that and it could be right in the middle of the data set, so we have no real means to spot it. And if the data is huge, you don't want to go through it by eye and watch every line. Imagine you have 100,000 lines in the file, you can't do that. So let's do that automatically. So to do that, we are going to use a method called isNull. So let's do df isNull, and I want to show you what comes out of this. And you can see that what we get is a data frame where everywhere that the numbers are not null, if you want, we have a false, and we can see that in the last line, indeed, we have some true values. So this is at the level of the total data frame, but we could have said, oh, I want to spot where this high, where we're missing this high value here. So we could have done high here and do that. Because it is, when you look at this data, you have no idea whether the missing high, the missing low, the missing close, the missing volume, etc. is actually on the same line. So let's say we looked for high. So that's what we would get. We see that there's a missing high at the last line. Again, this we were able to see it because it's the last line, but it could have been in the middle. So what we can do is use this magic lock method that we've used before and just do df.lock of df high is null, etc. So if we do that and we run this, we find that the line where high is null and actually it's a non-value, so that means not a number. And we see that it is on the line 2,919. Great. And actually, here as well, we realize that we're quite lucky because everywhere where we're missing a high, a low, a close, those values missing are actually exactly all at the same line as the last line here. So, yes, again, we did knew that because we saw it, but imagine that was right in the middle here, then we wouldn't have known all this information. So that's why all of this is really handy. Okay, so now we should do a bit of thinking because we realize we have one line in our data set that's not functioning properly. So how can we use this? What can we do to deal with this? Well, let's think about it. What happened here? Why do we have the final line of this file when we have the time, the open value, but not the high, the low, the close, the volume? Well, quite naturally, probably what happened is that, well, when we extracted this data, we took the data from whatever website or etc. about the Apple stock. Well, it was right in the middle of a trading session. So we knew the time of the beginning of that trading session, we knew the open value, but since this trading session wasn't finished, well, we couldn't know the high, the lowest value, the close, and the volume. So in that context, and because it is indeed the last as well, it kind of makes sense to simply delete it. Okay, how do we do that? Well, we actually use our drop function again. So df drop, and then what we'll do here is that we'll just paste the index number directly. And let me print that df again, and you can see that indeed we have no longer that last row. So if I do a little df describe, we'll see that things look better. Indeed, now we see that the count gives all the same numbers in that first row.
That did not work.
DF
DF equals DF dot drop 2919 DF. Why didn't that work?
And we do X number directly, and let me print that df.
Let's try this again. What? Why are you not working?
Again, and you can see that indeed we have no longer that last row. So if I do a little df describe, we'll see that things look better. Indeed, now we see that the count gives all the same numbers in that first row here, and we also have lost our volume MA column. Right.
If you live in a Maryland district
Shut that
that
one
has
worse.
0 DUIs in the last 5 years,
Okay, now and again, so df drop, and then what we'll do here is that we'll just paste the index number.
That is what I did.
Directly, and let me print that df again, and if I do a little df describe, we'll see that things look better. Indeed, now we see that the count gives all the same numbers in that first row here, and we also have lost our volume MA column. Right. Okay, now let's tackle this time column.
I don't know what it said.
Job specified labels rows raised key error.
Alright, we're gonna come back to that.
Because these numbers honestly then really not intelligible for a human. So what these are, they are timestamps. This is a pretty common convention in financial data. So they're actually the number of seconds counted since the date of 1970. So we need to convert this back into a date. So for that, it's quite easy. We'll use a command, a pandas command, and let me paste it directly because I don't quite know it by heart.
Okay, so I think it was this one he's using.
So there we go. So what we're doing here is to say, take the column time of the data frame and change it to a date time. So for that we're using this toDateTime method, and we're saying the df time is actually in a unit that is in seconds. So this method converts a number from seconds to a date time, so a date that we can understand. So let me run it, and so you'll see that what comes out of it is now much more understandable. Indeed, the first row, we see that it was the opening session was in 2011, and actually you now also realize the kind of time frame of this data set. You see that it is a daily evolution of the data set, because you see that every new line starts at a new date. Okay, I think now it's time to deal with this little zero that we saw here, which didn't make much sense. I remind you that this means that there is one line in our data set which has its opening value that is zero, which is not really physical, so we'll have to kind of try to understand why and deal with it. So again, the first thing is to find where this happens. So let's do a little search. So for that, we'll do df of what? Well, open, and we'll do a equal 0. I remind you, double equal is for equality. But if I do that, well, okay, I see falses everywhere. So it is in this setup that I mentioned before. So it's neither at the beginning, neither at the end. So it's in the middle, so this is not helping us. So we'll have to go and use the lock. So we'll do df.lock of df open equals 0. Okay, if we do that, we now find exactly the line where this is happening. So it's on that date, this line here, and we see that we have an open that is 0. But interestingly, what do we see? Well, that the high, the low, the close, all of these values make total sense, they're logical, etc. So from this, what we deduce is that something went wrong somewhere when this data was acquired, and we don't know why, but we have a 0 here. So we must deal with this. How can we do it? Well, it depends on how one intends to use this data. Maybe you're okay with just deleting that line, or maybe you can do an approximation, something more intelligent that will allow us to keep this line. And maybe a good thing to do is to say that the open would be approximately around the average between the high and the low of that trading session. So it is obviously not the exact value, but it is a quite plausible approximation of that. So you can replace this number by the average of the high and the low. We'll do that a bit later. Finally, one nice improvement we can do to this data frame that I mentioned is to actually make the time column our index column, because this will give us some really powerful tools that we can use. So how do we do that? Well, we're going to use a method. So this is going to be def.setIndex. And in setIndex, we're simply going to say, well, time. So let me show you a little trick here. Instead of doing def equal def set index, there's another way of doing this, and it is to use this keyword called in place equals true. This just means that it will directly apply this to this df data frame that we've defined before, rather than saying df equal. Up to you, choose which one is best for you. This in places equal true is a keyword that you see often in all the methods, data frame methods, which change the shape, the form of the data frame. Anyway, so let's run this, and what do we see? Well, now indeed that index. Column has been removed, and that index column is now the time column. So from doing this, what have we actually achieved? Well, we'll see that later in this course, but now it will get quite handy to do some plotting with this, where the plot will directly understand.
Yeah, I don't know. It's saying df.set_index.
Open parenthesis time, in place equals true, and then I get this.
The index being a date, and I'll plot the date nicely on the plot. But something else that you can do is now to use df lock, and for example give a date here now because we've changed that as an index. So let's say that we're doing 2023 03, and let's do, well, March, so, and the 11th. And what do we get? Oh, actually we get nothing. I did that on purpose, just for you to realize that trading sessions don't happen every day. There's some days, for example, the weekends or the nights or things like that, where the stock is not traded. So here I've just picked such a day, but if I did, for example, maybe the 13th.
See, he's getting something different at this point. Is it every time I try to mess with the time? I try to drop that there.
It's so do you kind of try that so how it's simply gonna say, well, time. So let me show you a little trick here. Instead of doing def equal def set index, there's another way of doing this, and it is to use this keyword called in place equals true. This just means that it will directly apply this to this df data frame that we've defined before, rather than saying df equal. After you choose which one is best for you. This in place is equal true is a keyword that you see often in all the methods, data frame methods, which change the shape, the form of the data frame. Anyway, so let's run this, and what do we see? Well, now indeed that index column has been removed, and that index column is now the time column. So, from doing this, what have we actually achieved? Well, we'll see that later in this course, but now it will get quite handy to do some plotting with this, where the plot will directly understand the index being a date, and it'll plot the date nicely on the plot. But something else that you can do is now to use df lock, and for example,
Oh, goodness. Alright.
or give a date.
It'll be here soon. Take a break from this, because I'm gonna have to research why that's doing that.